And obviously, Xavier, thank you very much. You're a local Barcelona resident, and it's finally good to be you over here to do a talk for us as well. The other thing is, this is starting to become a real serious meetup. Okay? I was just looking a second ago, we've got 388 alchemists, 388 people that have actually joined our youth group. That's a fucking amazing achievement. When I've sat there with one of my work colleagues, Mo, put your hand up. When we decided to put this thing together, our first meetup, I think there's a couple of faces that are still here from the very first meetup. We've sat around in our old offices on like 2 sofas. And now we actually run out of space in our old office, then we run out of space in our new office, and now, you know, we have to take advantage of a place like this, which is fucking amazing, okay? Amazing. And I can guarantee, maybe a couple of them are here to see you, but generally speaking, they're here for the user group, okay? That wasn't supposed to be funny. Okay, so yeah, over to Codeworks, please.
Cool. Well, thank you so much, Z. Thank you for organizing this. Thanks for inviting José. Thanks for doing it here. So I guess, how many of you are developers? Let's do a quick round. Today it's kind of an easy question, but lots of people. Right. So you probably all of you know already what a coding bootcamp is. Some of you might like the idea. Some of you hate the idea. And if you don't know what it is, you're going to find out in a moment. But since you probably already are working in development, in case you have friends who want to enter like a tech company or become software engineers, don't want to go back to another 4 or 5 years of university, want to get started. Since coding is also a lot, it's something that you learn by doing, and you learn through experiences. I'm sure many of you can relate to. And they like Barcelona, want to come here, maybe get them in touch with us. And I'll just leave it here because we have an amazing guest today, and we want to hear his story. So just going to leave you with this short video, and then welcome José on stage. Codeworks is a place for people that want to learn coding, to knowing very little to becoming a good developer.
So for me, coding is very empowering. Being able to build something that people will use and see that, and at least say to myself, if not to my friends, like, yes, I did that. That app you use on your phone, like, that was me.
If I had to choose where to live, I would choose Barcelona. You have the sea, you have great people. The city itself is very cosmopolitan. The startup scene here in Barcelona is booming as well.
Looking around the industry and speaking to some of my friends in the industry, everyone advised that JavaScript is the way of the future because front and back end databases.
Yeah, there was another thing that appealed to me, the timeline. Like, it was 3 months long, and most programs are like 8 or 9 weeks.
Really wanted to concentrate on JavaScript, so I just kind of began Googling and was trying to find a JavaScript bootcamp, and then I found Codeworks.
There are only a couple of boot camps in the world that have the same kind of process.
There is a pre-course that takes about a month, doing it part-time, and it's remote. So students do it from wherever they are.
Just the pre-course was enough to get a job, I think.
Well, in my mind, I'd imagined there was going to be like loads of people, and we were kind of going to get lost in a crowd, but we're a small group.
Get to have fun. That's right. Give it one shot.
I was surprised at the amount of attention that we all get and how many questions and how attentive the teachers are to our problems.
The relation between instructors and the students is so good. The important thing is that we spend so much time here talking about tech that when we go out,
Let's see if we can get to at least one.
we are like a group of friends.
The juniors was compact, 12 hours a day. But you slowly get used to the roller coaster ride every day, and you start enjoying stuff. When you finally start understanding and things start clicking in your brain,
You have to go around blindfolded with sort of software in your ears not to learn here.
To get out of your comfort zone. You have to build 3 apps during the course. All of this is very demanding at the end of the 3 months to be like ready to enter any professional development environment.
I think I should push my brain to the limits I didn't even know that exist.
I finished the bootcamp the 15th of December, and a couple of days later I found
Graphic designer, and after finishing Goldworks, I realized that there was another whole world different from that. You get offers almost every single day.
I'm doing things now that I couldn't imagine.
Cool. José, share your story with us.
Okay, Jose. You're probably wondering why we have 4 chairs here. Has anybody done a fishbowl session before? No? Park bench? No? Okay. You sit down. Okay. So this is the idea of this part of today's event is it needs to be interactive. It's like a Q&A with a couple of rules around it. Okay. The idea is there's 4 chairs here. One of them always has to be free. Okay. And the free chair is for anybody in the audience who must ask a question. Okay. Kick off a new conversation. You can come over here and sit down on the chair. Once somebody sat down on the chair, somebody else needs to get up from the park bench or the fishbowl so that there's always a chair free. Okay. We can kick it off with a couple of different topics or whatever. So I've got a couple of things in my head that we can start off with. But obviously there's 2 empty chairs here, so those 2 empty chairs need to be filled. Anybody want to get up and start? Well done, Ollie. Anybody else? One more person before I start pointing fingers. Come on, get up, get up. Come on, join. So make yourselves, comfortable with getting up or wanting to.
Just getting this from my wife and I can store the stone. I'm looking for more information.
Oh, okay, all right, fair enough. Okay. Who else? Mo?
That's a good.
Come on. Okay, so now we've got the bench as full as it can get. So remember, 1 chair always needs to be finished. We need to start to come up with some topics to talk about. Okay, this is really, really loose. I can go back and say, to get some conversation going beforehand and all the rest of it, so we can start to talk out any different things. Does somebody have a burning subject that they'd like to start to talk about initially?
I've got one I'm curious.
Okay, so one you're curious about. All right.
So in Phoenix 1.3, there's this introduction of bounded concepts. And I haven't really been able to get a clear idea about sort of direction that. Okay, is there going to be a move towards domain-driven design in a big way, or is it just to sort of maybe think about how you break your app?
Yeah.
Okay, just guys, if you can't hear, okay, let me know, raise it, and I can repeat the question. Yeah, so in Phoenix 1.3, there's an idea of bounded context being introduced to the web framework, okay? And what was the rest of it?
There's been a bit of discussion about what the intention is here. It's a concept from domain-driven design, but there hasn't really been much in-depth talk about what's going to happen.
Yeah, so it's not in complex context.
Right.
It's just a context. So the idea, so I'll maybe throw back a little bit and see talk about the issues we're seeing and what issues we're trying to solve, and talk a little bit about the literature behind it. I don't think we talked about it actually. Is everyone here familiar with Phoenix? Okay, not everyone. All right. So
how many people are Elixir developers here? Okay, all right. But on mic, there's lots of feedback. Okay, so but you're aware of Elixir. How many people are actually aware of Elixir, right? Both. Yeah. Okay. It's not like JavaScript conversation or anything like that. But do you want to start with telling us about what Phoenix is now?
Yeah, all right. So Phoenix is a web framework that is implemented in Elixir. And when Phoenix came out, it was a full, let's say, MVC framework. The same way you're going to find MVC frameworks in Ruby, JavaScript, and so on. So you would go and there is a directory called models, there's a directory called controllers, there's a directory called views. And one of the things since the beginning that was very interesting, even when designing Elixir and then working with Chris and Phoenix, was exactly how are we going to. It's a new programming language, it's a new environment. We have a lot of functional ideas floating around. How are we going to make that fit with the ideas that we have elsewhere in our history? And then one of the things that we did in this process. So when Phoenix 1.0 came out, we had, exactly as I said, the models directory, controller directory, view directory, but it had a couple differences, I think, with other how other languages would solve the problem. And the main difference was actually that we had a very clear boundary. So if you're coming, who would say they are Ruby developers, please? So I can try to get my metaphors in place. JavaScript developers. All right. Java. All right. Whoever.
It's all right. It's all right. Stick your hands up.
Yeah. And what have I forgotten? Not that, all right? Right. Erlang. All right. So one of the things that we did was, we need to talk to the database, right? If you're building a web application and so on. And one of the things that we did is that we have this library called Ecto. And Ecto, we had something that was called models. But as a model, it was mostly about data. It just had data. So, in a lot of frameworks or things that you use to interact with the database, you can think that you have a post model, a post abstraction. And when you want to save the post to the database, you would call something like post.save. So, so it's classic object behavior in the sense that you have the data, and then you have the behavior there, you have the method, and you just call whatever you need to in that thing. But in Elixir, it's a functional programming language. We don't have that. So one of the things that we did is that we had this kind of model looks like thing, but they were mostly about data. And we had the repositories, and the goal of the repository was exactly to encapsulate the database. So using the word repository can cause some confusion for people coming from some particular technologies. It's easier to think about it as storage, for example. It's really something that's going to encapsulate the commands and the things that you can do directly against the database. It's not a pattern, science pattern anyway. Cool. So one of the things that we did was when the Phoenix, in Phoenix 1.0 is that, so we had like the data, and then we have this thing that represents the database, and we need to, and every time I want to load something, I want to insert something to the database, I need to use this repository. So, and what we did in Phoenix 1 was that every time you wanted to talk to the repository, you would do that in the controller. So, for example, if you wanted to update something, you would receive parameters from external request. You would change the thing with the parameters that come from the request. And then in your controller would say, okay, now I wanted to update the entry in the database. And that's how it was. And the reason why we decided to do that in the controller is because one of the tenets that we have in functional programming is in separating what is a side effect. So, for example, anything that can be stateful, input, output, all those things, there are side effects. So how can if anyone wants to jump in. So how can we talk about, so for example, yeah, it's very,
So for us to talk about side effects, okay, so let me roll back. So we can think, and related to side effects, we have something that's called pure functions. So pure functions, they are functions that every time you call them with the same input, it needs to give the same output back. So you can think there are things like when you have objects, for example, and that object has an internal counter. And every time you call a function, you increment that counter, and every time you call a method, you increment that counter and return the new value of the counter. That thing is not pure because you're calling it. So you can have like an object, and then you're calling increment, dot increment, dot increment, dot increment. Every time you call it, you're getting a different result back. So and we like to say that those things, when you have state, for example, and the things change, they are very hard to reason about, right? Because I'm calling the thing with the same argument, with the same parameters. Why is it giving me a different answer every time? So in functional programming, we have like kind of this idea that we want to separate those pure functions. We actually like to write code that obey this principle where when it's given with the same argument, it always gives the same response, the same result back. And we say that's pure code. And code that does not do that, it's usually code that has side effects. So for example, something that writes to disk or something that reads, so file.read, something that is going to read a file from disk. That is a code that is not pure, right? Because it depends on whatever is on the disk. So if I imagine that I'm trying to read a file called foo, sometimes it's going to return the content file, but something else, or you can go and change the contents of the file, and then I'm going to ask it for foo, and it's going to give me a different answer. Okay, so going back to Phoenix, so we have this idea where we like to separate code that is let's say constant, that is pure, and code that has side effects. So we chose the controller to be the place where we do this kind of action, like talking to the database, because the controller is also the place where we read the request coming from the client, and it's the place where we send the response to the client. So it made sense to centralize all of the side effects there. Okay, so now everyone, does anyone have questions before I even go more and more? All right, so that's where Phoenix 1.0 was. But then we started to see that this idea of it has some flaws in it. So one of the issues was that, imagine, for example, that you want to create, you open up the terminal, like the live terminal in your production server, and you wanted to do something. Because all the data access was encapsulated in the controller, it was actually really, really hard to even get like, well, I want to, imagine that you need to update something, especially in a moment, right? That was really hard because all the everything that would access and talk to the database, it would be in the controller. You would have no encapsulation for that. And Phoenix, and some other issues so Phoenix has this very cool feature which is called Phoenix channels. And the idea behind Phoenix channels is that you can have the client connected to the server and you can exchange information all the time. Information comes and goes. So if you're using the browser, that's usually WebSocket. So have the client connected to the server with WebSockets, and information is coming and going. But we could go on and talk about channels because there are a lot of interesting designs and there are like interesting scalability properties. So when we're designing channels, at some point we ran benchmarks and we're able to get 2 million connections on a single server. So it scales really well and has a bunch of interesting properties in terms of concurrency and so on. But anyway, so we have these channels, which is just another interface to your application, right? It's just another interface to your server. So sometimes the user sends a regular GET or POST request, and that goes to your controller. But if the user is interacting through the WebSocket, they're going to get to this channel that needs to do some different kinds of actions. And then we started to realize that there was also a lot of duplication between the channels and the controllers, exactly because all the data access was in the controller. So if you had to access the data in the channel, there was a lot of duplication. So at some point we're like, okay, we obviously need to revisit this. And there were a lot of pains that we kind of inherited from other frameworks that have the same flaws. So for example, I don't know, so this is an issue with Rails. I don't know about the other frameworks that we use, but for example, in Rails, when you go to a new application, you have like app models, and in Phoenix it would be web models, and it has a bunch of different files, and you have no relationship, no understanding of how those files, they relate to each other, or how they even relate to your domain, to your business, right? It's like, they end up reflecting more the database structure than the business structure, the domain structure, right? And if I want to see how the database looks like, I'll go and ask the database. I'm not going to have that reflected in the, in my application. So, and then we had a lot of back and forth on how we should solve this. So maybe we can separate the read and the write operation. So we would create modules, and then depending if you're trying to get data out of the database, if you're trying to write, it would behave differently. But at the end of the day, we chose an idea that is actually very, very simple, but even though it's causing a lot of confusion, exactly because it's new. And so what we said is that, well, what if, very revolutionary idea, what if we just organize our code into modules? So in Elixir, all the code that you write into modules. It's just a group of functions, literally a group of functions. And that's how you write your code. So we thought that, oh, so what if instead of having like these repositories scattered around, like those data structures flying around, what if we just organize everything into modules? So for example, if we go with the classical blog post, one of the things that I'm going to have is that I'm going to have a posts module, and that's what we call the context. It's just a posts module, and everything that I may want to do related to posts is in that module. So that module is going to have functions like find post, create post, update post. But what is interesting about context is that they're not meant to be a mapping to a resource. It's not meant to be, oh, I have posts, then it's a context for posts. No, that's not it. If I'm writing a blog post, it's very likely that blog post is going to have comments, right? And where is the perfect place for comments to be? Inside the posts context. Because even a lot of times when you're fetching comments, right, that is, every time we fetch them, it's always in the scope of the post itself. It's very unusual for us to get, for example, like all comments regardless of post. So there are things that they are naturally together. So now if I go into, so the hope is that in Phoenix 1.3, when you go to a more complex application, what you are going to see is that you are going to see a bunch of directories. You're going to see accounts, and inside the accounts directory, you are going to have maybe 5, 6 files, and files in there, they are going to represent, some of them they're going to represent database structure. So some of those files can be, if I have an account context, so some of the things I'm going to have in there is the user itself. Maybe I'm going to have tokens for the user to access the API, this kind of stuff. Maybe I'm going to have anything you can think related to users, the part that needs to do email management and all this kind of stuff. It's going to be there, and it's contained. And then if you're building a store, there's this whole part that is related to payments and is related to order. And you can get there and you can put that into a context. So
related to users. So users are a really good example of a model that would be shared across different contexts. So for instance, if you're in your post context and you want to join on a user, how do you manage that overlap between those contexts? Would you just have a user ID stored within the post context and not think about anything to do with the model, or would you?
Yeah, so that's exactly one of the topics for discussion, because now if you're thinking about contexts, right, and then we are splitting things apart, then one of the things that you want to think about is your boundaries. And that's the word we're using in the beginning that, so let's go back and then we're going to jump straight to that. So what are context? They're just modules. They're just, it's a module and a directory. That's basically it. So, and getting the word was kind of hard because it's really hard to find a word that does not have an existing connotation. So we said like, context is probably our best shot. It's going to have some association with BDD, and it's relatively close to the BDD concept, the DDD, sorry. Getting my DDs, yes. But, but at the end, it's supposed to be a directory and a module that encapsulates all the functions you may do with that particular context. So, but then you start, and then when we describe that, we're using the word boundary, and boundary, it feels something very rigid, right? Like, oh, I should not break the boundaries. And so, for example, what about the user, right? Like, because the user, it actually goes through all your application. It's actually spread around. And that's a very good question. And we think that contexts allow you to model this thing in a lot of different ways. So I'm going to put the worst case scenario, right? And that's things I actually saw in actual applications. So who has seen like a user model with like more than 50 columns? All right, right? And that's exactly, and one of the issues is exactly because nobody stopped to think about that. Wait, like this user thing is reaching across a bunch of different contexts, right? It's doing a bunch of unrelated things. I have payment information here. I have information about friends. I have all these kind of things that, it's in this single place. So one of the things that you could do is that you could say, well, I have my user, and now when I'm going to do the payment stuff, I need a lot of payment information that is related to the user, but I don't want to add that to that user. I want to actually, I don't want to have that in that data structure. I actually want to have that in the payment thing. And then you can take a lot of different options. You can take the option, well, I'm going to create then a user payment kind of table that associates with my original user table. One of the things that you can do with Ecto is that you can actually say, so Ecto is our database layer. If you say, no, but I don't want to split that at the database layer, I actually want the same thing to have part of this information from the table and part of this other information. Yeah. So it gives you different options in the design. And then you can say, well, so what about join queries? That's a very good example. All right, so what about the join queries? So we're going to say it's fine. It's fine if if in some particular context, you kind of need to go and read into some particular data structure, and Ecto is actually going to help you there, because if you try to reach a field that actually doesn't exist or is not defined,
So would your user model still have relationships defined into other contexts?
I was just getting there. So, if for the join queries, sure, you would do that, but the place where I would draw the line is that I would not have that leak into my data. So I would not do relationship across context. That's where I draw the line. Because otherwise, you end up having this user thing that has, and then you have this huge data that has relationship across everything. So, yeah.
Sorry, I'll jump in here just very quickly to kind of explain my understanding of what a bounded context is, or context is in the new version of Phoenix. So I spent my career working in finance, okay, mainly in insurance, okay. So one of the things that is really important in Phoenix, an entity in insurance, an entity is a policy, okay. But in insurance, claims can't agree what a policy is, versus, so claims are the people when you have an insurance product and you need to go, you had a car crash and you need to go away and claim something. The whole side of the department doesn't agree what a policy is. Compare the whole side of the department, like the policy model within claims looks completely different to the policy entity model within the actual insurance product. And again, it's the same kind of thing as what we're saying here with user. So user, if you take any kind of business, think about when you're writing tests, user-driven acceptance tests. So a lot of these tests, a user might be for your admin staff. That user is completely different to a user that's actually using the website. And this is where bounded context, where I think about bounded context, I think about literally, physically, where people sit in an organization, for example. A user within marketing is completely different to a user within sales. It's completely different to a user within the design team or within customer service. You know, whatever your organization is. And I think what Phoenix 1.3 does is it, with this kind of context or bounded context, is it hopefully nudges you to think about how you're actually going to go away and design your system slightly better. It gives you the ability to go away and say, well, you can actually have a folder over here and grab all of the stuff that's important for marketing or stuff that's important for your internal application and put it in that context, whether that context is an application or a folder structure or whatever. But it forces you to just think about how are you going to be integrating with this code, whether that ends up being database models or not, or whether that, so what effectively you can end up having is a Phoenix umbrella application with 4 or 5 different user models, and each different user model is actually completely different. So you might have a customer services user, and you might have a website user. And again, like José was saying, was when you start to go away and think about database relationships and so on and so forth, I totally agree. You know, the user within the marketing department, don't ever think of joining in that user with a user within the sales department, because in reality, the marketing department have their list of users, and the sales team have their list of users.
Yeah, so to sum up, the idea behind the context is to help you organize your code into modules and directories. It's basically a module with a bunch of functions, and behind that module, and that module may be representing different kinds of data but unrelated, right? So data that's kind of related together. And just one point to add, so like if you want to go into with this view that, you know, I have like the sales context, I have the marketing context, it works great, but one of the things that we were getting as feedback is that a lot of people, and that's an advice I'm giving to everyone. So if you go in and just try, and you want to try Phoenix 1.3 and then you're like, okay, now I'm creating an application. I need to come up with a context, but it's a brand new application. There is no marketing department, there is no sales. What I'm going to do? Someone even said a joke, like they asked if they were able to produce any work during the day. And they said no, because they could not think of a good name for my company. So they just flagged. So if you are in that position, right, where you are, well, I'm actually not sure. Just start with the parent thing. So if you're going back to the blog post or going back to even if you're starting with the users, you're not sure how to call that users. And then as your application grows, you're going to start to see, well, this thing is more related to the users. Well, this thing is more related to orders. This thing is more related to products. And you can, and it's going to grow naturally. And even if you're not sure, as you move things around, you're going to get more confidence. I like to say that in the worst scenario, in the case where like you really can't figure out anything and decide to go with a one context per resource, which is the thing you should absolutely not do. Right? In the worst case scenario, it's going to look like all the applications that you wrote before, and you didn't organize. So I think that there's a lot of potential in the idea in just leading to better code organization and have a better overview of how everything is structured. All right? Questions? Yeah. So yeah, so going back to users. Yeah, so the question is, let's go back to users and say, am I going to allow a user to relate to other things or no? So you need to relate. So for example, if I have posts, the posts, they need to have a user ID so I know who created that thing, right? The thing that we wouldn't do, so you need that relationship in the database, and you need that relationship to the joins. The thing that I wouldn't do is that I wouldn't just go to my user schema, so we call them schemas. So schemas in Elixir, in Phoenix in particular, it's something that maps to an external data source. And that external data source can be a CSV file, but in this case, it's a database. So we have a user schema that maps to the database. So the user schema with accounts, it wouldn't have a posts field, right? That's it. So if you're familiar with Elixir and Actor, or familiar with Rails, it means that I wouldn't add as many posts to my user, and that's it, right? But the post, on the other hand, it needs to know that, and it needs to have the same. So you have a more clear mapping between relationships. But at some point, you need to do, you have like complicated joins that you need to run there, depending to get, when you need some particular kinds of data. And sure, you need to do those queries, like if you have a very strict boundary, then you end up bringing, so who is doing like services kind of application, where you have a bunch of services and you need to talk to each other. Yeah, so one of the issues that we have with services is actually when you need to get any information that is all across the services, that's really, really hard, right? So if you have this strong, sure, if you want to have a strong boundary, yeah, go ahead for it, right? But you need to be very careful, because otherwise you're bringing all those issues that you can have with services and strong boundaries where the APIs keep growing, and you need to keep all the data separated, and all those kind of issues you're bringing to your application. And very likely you don't want that, right? Otherwise, you may as well make them separate applications and call it a day. So yeah, so regarding users, sure, you still need to have the relationships. You want to keep the database. One of the things that we also say a lot in Elixir, like, you don't want to make the life harder for the database. So we help you define the keys, foreign keys, and all this kind of stuff, so the database functions correctly, and you should definitely continue to use that. You should just be careful of all those relationships linking to something like a user that have a bunch of relationships. So those particular data things to remain constrained, and yeah.
Okay, just a couple of questions here. How many people work in a team of less than 10 developers? Okay, how many people work in a team greater than 10 developers? Okay.
And how many people?
Exactly 10 developers. Okay. All right, and the rest of you? There's a couple of people who put their hands up. How big is your team? 10. Less than 10. Okay. All right, cool. How many people work for startups? Okay, and the rest of you, enterprises? Okay, and freelancers? Okay, there's a couple of freelancers. I think this is important as well when you're thinking about architecturing out these solutions and stuff like that. So there's sometimes where obviously you need the new app go model, and I need to get something out very, very quickly. But then there's other opportunities where the application is actually massive, and you need to start to think about how different departments or different contexts work on that.
Just on that point, I was going to say, one of the things that I really like about Elixir and functional in general is that it's so much easier to refactor your code. So it's very easy to just throw some code together at the start just to get something on the page, and then gradually form it into cohesive concepts and gradually pull things apart. And I think you've now got various stages with Phoenix. So you've got these contacts, and then you can pull them out into an umbrella app. And then maybe from there you move them into being separate microservices completely. So you've got this really nice progression from the situation where you have no idea what your domain is about to maybe 2 or 3 years down the line where you've got a lot more experience, you've interacted with your customers a lot more, and you've been able to reflect that information in your code base without having to do a big rewrite or a mammoth refactoring session. You can get there very gradually.
Okay, I just had a question over here.
So something OpenSea.
Yeah. We have a chair for you.
No.
Yeah, we will. We have a chair for
So something you mentioned about designer, and I think the key there is dropping the username. Because you have a designer, you have a marketeer. But something I've experienced and I've seen in code base is that it's often easier to be very specific about what something is than to resist the temptation to put another column onto an existing thing. So that's something to consider.
Can you give us an example?
I mean, the user is a great example. Like as I said, it's really easy if you just need to just add another column, and then there's your 50 column before you know it. You know? Yeah, one column at a time. Man of doom.
Okay, great. All right. Sorry, one more. Let's go. Questions, statements?
Yeah, it's just a question about what you said. At some point you start talking about services. What I do usually is I do different services. And there's a common pattern which is propagating events across different services. So let's say you are a user in a post.
You want to come up? There's a free sync word here. It's not a quick question. It's not a quick question.
Okay, so what you want to do sometimes is instead of making the user context query the post context, you said preventing the temptation of a new column. When you create a post, you submit an event. So in Phoenix, is there a way to propagate and subscribe to events? How does that work?
So you need to bring in external technology because you want to have everything that's going to give you the delivery guarantees, and so you need to bring something that is going to allow you to publish the event and guarantee that whoever is interested on that is going to get. So be it RabbitMQ or Bash Kafka, or even if you're doing a regular job processing thing, but you need to bring an external tool. But there are a bunch of things available.
I mean, you can think the same with databases, for example. You can store the data in memory or an SQLite database or whatever. But the important thing is the abstraction layer, right? So as you have Ecto for data, is there any project or abstraction for publish, subscriber, or event management?
There are some, and so I think there are now 2 or 3 projects that are exploring even event sourcing in particular and going more into that direction. But I won't recall their names. But it's definitely an area being explored.
Yeah, so you suggesting to use an external solution? Like I know, like Erlang is very good at those kind of things. So wouldn't you suggest instead using a solution done on top of Erlang and just connect like your nodes and be able to just propagate events? Or do you think that's not reliable enough? Like you always need Kafka or something like that.
Yeah. All right. So okay. So if I say you need persistence. If you need persistence, then I would pick an external solution. Otherwise, you'll be re-implementing the whole queue system, right? Because imagine like, oh, I want to dispatch an event, and then say, all right, let's do that. Let's implement Elixir, Erlang, woohoo, PubSub, we have that. We can send messages between nodes. And then I would say, well, have you guaranteed that the other node received the message? Oh no, I haven't. Yeah. And oh, and what if this node goes down? You want to actually have some kind of consistency between the nodes, and yeah, I need to probably think about a distributed protocol to guarantee that. Oh, and what about backups as well? You probably want to back up the data if something goes wrong. So you need to also have something that is generating the data where you can back up. Yeah, I need that as well. And then congratulations, you have a half database or a half queue processing thing that is nowhere as good as everything you have out there. So that's why the word is persistence, because if it's about real time, if it's about like fire and forget, then sure, then you don't need everything like that. That's Phoenix PubSub. So Phoenix comes with a PubSub thing that allows you to broadcast messages between nodes, everyone receives them, but it has no guarantee at all. It's about things that I want to send to someone. If they are there, if they're not there, I don't care. It's like, and we have a bunch of interesting things that is built on that. So Phoenix Presence is a thing that allows you to to show who is some particular channel. So if you're thinking about a game with who is on that match right now, if you're thinking about building an application where you go out with friends and you all track yourself together, they will all be Phoenix. You can use this Phoenix presence, and Phoenix presence tells you about who is there right now, and that's it. Like, if you want to keep when the user join and all this kind of stuff, then you go and iterate to something that is going to give you all those properties, right? So that's a very good question. That's a very common thing, a very common point of like, well, why not? I can just use something. And then if you want to stick with the Erlang VM because you're already deploying things that runs on the Erlang VM and you already start to get some knowledge on how to customize that, then sure, use RabbitMQ, for example.
So do you think that having imagine that someone writes an Elixir solution that's as complete as any other one, would you think that would be a better option so that you can deploy it with the rest of your Elixir application? No?
Yeah, so if someone says, well, I'm implementing an Apache Kafka in Elixir, then sure, yeah, you can choose it to run it together. You can choose to run it separately. You're going to have this choice.
Sorry. The reason I pointed at Mo was I came from .NET, and .NET I did some work with Eric Evans. He's the main guy that coined the DDD thing, and he wrote known in some circles as the Blue Bible. And I did some work on CQRS as well with Greg Young. I don't know, the .NET guys probably know about it, but how many people in the room know what CQRS is? Okay, it's getting more familiar now. So CQRS stands for Command Query Responsibility Segregation, and I think that's basically where your question was kind of coming from. But even if you think in CQRS, the biggest movement in CQRS is coming from .NET. There's no kind of CQRS implementation within .NET. Greg Young was the main person that coined CQRS. He still pushes on implement CQRS as a design pattern, if you like. Don't go away and think about building out a full CQRS implementation. There is one built by Udi Dahani, who's another .NET developer. It's called N-Service Bus, and that is a full system. It now, I believe, has areas where you can draw bounded contexts and have messages publishing from one side to another side. But that's effectively a new IDE for your organization for publishing events from one place to another place. I think for me, it would be too early to get something like that within Elixir. I think .NET's been around for a long time, and they've been doing this for a long time.
Yeah, but just to go back to our original point, but that's exactly it, right? If you're building all those services and you're starting to get issues where the APIs between them is just growing, and you have services where it needs to request something to this, that request to this, that request to this, and come back to this, right? You want to move to events, right? That's for sure, and that's not what we're discussing here. Like, that's currently what you want to do. Yeah.
I wanted to ask that because I remember when I started doing Rails, for example, the framework almost tell you what to do and how to do things, right? Because that's to some extent a framework. So my question was, given that Phoenix is moving to this organization, are you guys supporting having events to prevent doing things like the wrong way? If that's maybe there's another solution to prevent coupling and adding extra columns and prevent this maze of calls, right? So maybe have you ever think about the idea of providing some sort of support for event propagation?
Yeah, so I don't think that we have any plans right now. But the thing that we are doing is exactly related to education about those issues, right? Because otherwise there is a chance that everything is going to be taken as a silver bullet, in the sense that people say, oh, and we saw that happening with some Elixir concepts. Like, so we were talking about umbrella applications, and for those who are not familiar, in Elixir there is a chance, it's possible for you to create a project that has a bunch of applications that may be related to each other or not. So if you have large projects, you can isolate them in different ways and still have everything in the same repository, which brings some benefits. But we have seen instances of people saying, oh, umbrella applications is the secret sauce for me to have my code organized. And then they would later run into issues because if you're using that particular kind of design or kind of tool, it requires some disciplines and requires some responsibilities for you, right? And it's kind of like the same thing that we end up seeing. And it was exactly the question that he asked is like, if you just say, oh, I'm going to have hard boundaries, but you don't think about how that's going to affect the relationship and how that's going to require which disciplines and which effort that's going to require from your team, you're going to run into issues, which is how people, with microservices, they end up running into a bunch of those issues because they said, oh, I'm going to have microservices, and now all my problems are solved, right? And then time passes and start running into those issues. Yeah, they end up, how is it? They end up with, distributed monolith, right? Because it requires a lot more discipline to think about the boundaries. But it's also something, it's not also, I don't want to say it's like pointing fingers. It's in general a kind of process in evolution, right? So, now we are starting to see like almost everyone that is talking about microservices, they're starting to talk more about events because it becomes very apparent that, this thing of all the services trying to talk to each other, it doesn't work, it doesn't scale, it's not maintainable. So, yeah. Yeah, so, but on the other hand, like it makes no sense for us to start every Phoenix application as something that has an event thing and we impose boundaries for everyone, right? So, it's very hard to balance like all the different kind of systems you can do with it. And and we need to guarantee that everything is still approachable at the end. So just going back to Phoenix, so we were talking about umbrella applications, which is the ability for multiple applications running side by side. And then some people were saying, oh, what if Phoenix generates those applications by default? And I was like, no, that's going to scare everyone away because imagine like you want to try Phoenix and then the first thing it generates is your directory with another directory that has two applications with a bunch of duplicated files between them because each application is supposed to run on its own. It's very hard for you to make sense of all those things, right? Especially if you're new to Elixir, you need to learn functional programming, and you need to learn to think about processes. So no, it's like, we need to go into the proper direction, go with the proper steps. All right.
Thank you. Like I said, I think one of the beautiful things about Elixir is it's kind of growing slowly and naturally with what's happening with the community as well. If on day one all of these new faces to Elixir had to then go away and think about a shitload of other things that they haven't had access to in other technologies, I think it's risky. And I've seen guys that do CQRs, in fact, I've run events with them, stuff like that. The people that follow them can get very religious about CQRS everything, and you can get the religious people from Rails where convention over configuration everything, and if your application requires different logic, then go and build a different application kind of thing. We're coming to the end of this section of the talk, so what I would like to do is sorry, no more Phoenix. Okay, so. This is just a question for you, okay? So there's a lot of new people here that are new to Elixir. They've heard about it through whichever mechanism, but in maybe a quick sentence, why would you suggest people start to learn Elixir? Besides the fact that you wrote it.
Oh, that's a very tough question. Since it's collaborative, we just delegate.
So yeah, I'm just going to delegate. They say it's a good trait of a leader. So can please say why did we start using Elixir? Anyone, just concurrency?
Fun.
Yeah, all right, fun. Who else? Functional programming with familiar syntax, all right, cool.
Beautiful.
It's beautiful. All right. It makes sense. Tooling is a good one. Who else?
Yourself? What? Are you using Elixir yet? Not anymore. Okay. Okay. Why?
Why I started using it?
Yeah.
I started using it because I moved from Earth to Elixir.
Why did you start?
Good question, because
take the mic. It's important. I need to close the meetup after this.
So I moved to a company where we're doing PHP actually.
Now hold on. So you went from Elixir to PHP?
No, I went from a company doing Erlang to a company doing PHP.
Okay.
So then I had to change the situation. I had to choose a language. So I really love Erlang and Elixir, and the whole OTP thing is, I think, is great. I've learned so much from it. But when I try to introduce that into a group of people who are not very familiar with functional programming languages, it's very hard. So because programming is not just giving instruction to a computer, it's also communicating with your team, right? And by that time, Go was like released, I think 1.1 or 1.2. Was pretty stable. And they also have the compatibility premise, which is, this is not gonna change. The spec of the language is tiny, so that's why I moved from Elixir to Go. But I continue using it for like personal projects. So yeah, I mean, it's kind of a trade-off, right? So you lose the benefit of functional programming, what you said about side effects. You get idiomatic code in weeks or months, which in Erlang or Elixir you need like a proper training, which takes time. So yeah, the end is always a trade-off, right? So
also we could handle all data communicate. But in future, would you be able to add a deep or do
Right. So the question I would say like about design patterns and way of building applications. So in Brazil, we have this story where someone puts stones in the other person's shoes and they don't notice, and they walk with it for a year, and then when they tell them and took the stones out, the person say, "Oh, please put it back because I got used to them." But so I think, and we have like jokes where people they have like a slide, and then in one column it's they have like a bunch of different patterns, right? Coming from a row, and then in the other column they have FP, and then the patterns there are like functions. But so, and of course it's a joke, and people should not take it seriously. But I think in general, so we may not have like this design patterns per se, but we have guidelines and things that you should use to build the software. So we're talking about purity being one of them, and being a construct that you should use to make your software easier to understand for you and for everyone. And we have things that talks about extensibility, like so in Elixir we have protocols that they are, to me they are, if you're coming from one, they'll probably call that some particular design pattern, some particular way of doing things. But for us, it's something very natural how to achieve polymorphism. we have things like the visitor pattern, for example, which for us, it's pattern matching. You just pattern match and use recursion. So I think a lot of the things that they are right there, and in some ways it's like even in Post, so if you go back to purity and side effects, the fact that we have like immutable data structures, we're not even saying like, hey, there is this pattern that you can choose. We're just saying we chose that for you. That's going to be good for you. It's there, and that's what you should use. So I think so. So yeah, we don't have something like that, and I think would actually benefit of having materials like that. So there is Garrett Smith from the Erlang community, and he I don't remember the name of the website, but he's trying to document like different kind of patterns that we have in Erlang. It's actually very interesting read, and you can learn a bunch from that. And we need to have those discussions. But I think at the end, a lot of those things somewhat make this question hard to answer. Exactly, because some of those things, they're just the constructs that we use every day and rely on every day. And so they feel more natural and not something that you need to have like kind of mapped explicitly for you, like pick this, pick that, and pick that. And then there is a more complex part to it, which is when to it with
A few people. Okay. Does anyone use JavaScript for the front end or back end in your company? A few people. Okay. Right. So no, the only reason why I mention it is because you see there's like a few and they're graduating in 4 weeks. So it's a chance. I'm not trying to sell them because honestly they get away pretty fast. No, I mean it's happened like that in the past. I don't see why it would be different. But since you're here today and you're having a beer, it could be a chance to just have a chat and see maybe, I don't know, they're interested in what you guys are doing, and then maybe you can catch up in a few weeks and talk and interview them, or figure out if you're interested, go and mingle with them and have a chat. Thanks. And now we're about to introduce the next speaker, who's coming in a couple of minutes. Out of curiosity, since we're here, the people that said that you're using JavaScript, are using it for front end or back end? Front end. And front end. Are you using some framework, I guess? What framework are you working with? React? Yeah. React plus Redux?
Elixir?
React. Everyone React? React's taking over, right? Yeah. Okay. Cool. All right, guys. So, you want to take over? Okay. Sure. I'll move them around. You can just see the water. Okay. Thank you. Yes. Yeah. So I should talk to this thing. Bye. Okay. Yes. Have your pen screen.
Yeah. Okay, should we start maybe? Okay, I think I'm going to try to change the colors of the terminal because there's a lot of light. And perhaps very good. Fire. So, okay. Say it again. Open a new tab. Yes. Yes, but it opens. You see, with the same for schedule. It doesn't matter. You read it well. You can invert the color. Well, if you read it okay, let's leave it this way. Okay now. Okay. Maybe that's what. Use accessibility of Mac in regards to color society. Well, system preferences. Yeah. Anyway, well, I can open another one, and okay, okay. It's primitive, but it works. Right, approximately. Yeah. All right. More clear, right? Okay. Let's change this. Close this one. Reload. Good. Okay. Yes, it fits. Okay. Okay. All right. This talk is called a tour of the Elixir source code, and it's going to talk about Elixir, the project itself. All right. So if you are not familiar with Elixir, or I don't know, feel free to ask any questions, because in general the talk assumes some level of familiarity with the language or the concepts of the language. Okay. But feel free to interrupt me anytime. Okay. The project is big. There's a lot of stuff going on in the project. We selected a few topics to highlight, okay, that they found to be interesting. First, we are going to have an idea of the project structure. Then we are going to answer this question: what is Elixir written in? All right? How does the compilation work? has a parallel compiler, right? We are going to see how it works. And finally, I find very interesting the implementation of protocols, all right? We are going to see how it works as well. All right, let's go with the project structure. If you download the repository of Elixir, you find these things. Okay, this is a folder bin and lib. We are going to see what they contain right now. And man has just a few man pages, not a lot. And SRC has an application resource file that is there, I believe, mostly for legacy reasons, but maybe someday it's going to be gone. Then we have a bunch of files. Makefile, the project is managed with Make. So if you want to compile, you want to generate documentation, whatever, everything is in this Makefile. You just open it and you see how it works. All right, in bin we have these executables. Okay, so when you run Elixir C in a console, you are actually invoking one of these. These are shell scripts. There are shell scripts for Unix, and there's the alternative for Windows. Okay, and as you see, there's also the shell here, mix. All right. And lib has, so Elixir ships with all these things. For instance, mix is not like a third-party component that you download from somewhere else, or dependency package or whatever. It ships with Elixir. Elixir has these applications. There's a lot of stuff here, and we are only going to focus on the Elixir directory. The Elixir directory is the directory where the actual programming language is being implemented. Okay. If we open that directory, this is the structure. We have lib. We are going to see what this contains in a moment. Pages. We are going to see pages as well. SRC, test, and Unicode. Let's go for pages. Pages has a number of markdown files. And well, if you go to the documentation, those markdown files correspond to these pages. Okay, these things in this pages tab. Okay, so the guides are not in this repository; they are in a different repository. We are only these markdown pages, and of course the API and modules and everything. All right. After that, in Unicode, there are metadata files and stuff that allows building support for Unicode dynamically. Right? Those are here. Okay, an idea of where things are, how is this organized? From now on, all paths are going to be relative to lib Elixir. So I'm not going to put the prefix, every time. All right? Okay, what is Elixir written in? Okay, this is an account I did like maybe a couple of months ago. SRC contains Erlang files. This is the extension for Erlang if you do not know Erlang. Okay, SRC has Erlang files has 35 Erlang files. All right, and then lib has Elixir files .ex 76 files. This gives us an idea that there's a lot of Erlang here, all right? And indeed, if we count lines, we have 7,000 lines of Erlang, okay? Elixir itself in lib has 22K lines. So there's a lot of code here, all right? Without the documentation. So I did here like a quick script to strip the documentation. If we add the documentation, we have 35K. All right. So this is a way. So if you have the impression that Elixir comes with awesome documentation, this is the awesome documentation in numbers, right? So there's quantitatively there's a lot here. All right. So that's a hint. That's a hint of this fact. Okay, the thing is that the core of Elixir is written in Erlang, right? And José has written a lot of Erlang. I can say I've read a lot of code. The core is written in Erlang, And there's some auxiliary Elixir also that you would say pertains to that kernel, all right? And then the standard library is written in Elixir, and the majority of the code you deal with in your day-to-day is readable. You can just go there and it's Elixir and you can read it very, very, very well, all right? Okay, so Erlang. Indeed, if you, for instance, run this command, Elixir, and an Elixir file, that the shell script that I showed before expands to this line. For those of you that don't know it, this thing is the Erlang runtime system. It launches the Erlang runtime system, okay? And then there's a bunch of things here, but the one that I want to highlight is this line. This line is saying to Erlang. So Erlang, if you don't know Erlang, also is modules and functions, basically, okay? Elixir indeed inherits this idea from Erlang. It's modules and functions. So this is telling Erlang, launch this function, start CLI, which is a function of the Elixir module, the Elixir Erlang module, okay? And if you launch Elixir C, the compiler, you will see something like this. And if you run mix is just a script that is calling Elixir. So in the end, everything goes here, okay? So everything goes through this. This is the entry point to Elixir, okay? This file. This is the entry point. All right, let's go with the compilation. Erlang programs have these main phases of compilation, okay? So from the source code down to the bytecodes for the Erlang VM is not just one pass. There are several passes, okay? They are these are the main ones at least, okay? From the source code, you get an AST. AST is a way to represent in a tree structure the structure of a program. Let's say that way if you are not familiar with the term, right? From the source code, you get the AST and then some intermediate representations of the program that are called in jargon core Erlang and kernel Erlang. And in the end, you get the assembler for the beam, right? These phases perform transformations on the code. So you get first the AST, but that AST still is transformed in something else, and still simplify it and flatten it, and there's optimizations going on. There's a lot of things going on. Okay, so this is the main phases of compilation, and Erlang allows you to explore that representation in case you are curious. You can execute those things, and for the code in full URL, you can see what core Erlang looks like, what kernel Erlang looks like, and the bytecodes, etc. And there's plenty of talks online about these internals. So talks about how the VM works, how the assembler, how it looks like, what it means. There's plenty of information if you are interested in this. But I'm only saying this to put some context to the following thing. And Erlang comes with a lot of stuff in different levels. So on one hand, we have the programming language itself. Then you probably know there's OTP, which is a huge thing. Okay, the programming language is like the basic thing. OTP is about abstracting things and patterns and libraries and everything, And those are different levels. This level is tooling at the lowest level. Okay, so Erlang ships with tooling that you can use as a programmer to work with the Erlang internals. So Yak, for instance, is a parse generator that ships with Erlang. Compile is an Erlang module that allows you to compile things on the fly. Okay, so the Erlang compiler has a module that interfaces to the compiler. It's not like the compiler is not like an external, executable that is like a black box. No, it's ready for you. You can use it. And Elixir uses code. It's called in the Erlang terminology the code server. The code module allows you to load stuff into the virtual machine, okay, at runtime. And it knows about load paths and knows about where the file for that module should be, that kind of thing, okay? You have an interface to that level of things. In the end, binlib is a library that interfaces with bin files. So when you compile an Erlang program, but also when you compile an Elixir program and other languages, you get the bin file, okay? And the bin file has instructions for the Erlang virtual machine, which is in the end what runs the program, okay? That bin file has some specification, has some structure, and binlib is a module that allows you to interact with this file, okay? Okay, so as you see, this is, let's say, low-level things, okay, interacting with the virtual machine, with the bin files, but it's stuff that ships with Erlang, and then Elixir takes advantage, fully advantage of all these things. So in a bird's eye, we are going to see more details, following this slide. But in a bird's eye, this is what is happening when you run an Elixir program. You get the source code, then somehow you get the AST representation of that program, and then Elixir translates that Elixir AST into an Erlang AST, okay? Converts the AST into Erlang AST, and then executes this Erlang AST. So it delegates to all these low-level kind of utilities that we have to say, hey, execute this thing, okay? This is very simplified, but this is the main idea. Source code, Elixir AST, convert to Erlang AST, delegate to the low-level tools. And this is a very important thing. This does not depend on whether you are running Elixir or Elixir C. Both Elixir and Elixir C. So Elixir C, we think about Elixir C as something used to compile. Okay, we use Elixir C to get bin files, and we think about Elixir as something to run whatever program you want to run. Okay, well, there's no difference. They do the same thing. Elixir, AST execution. Okay, so it could be this can be surprising. So Elixir C is executing. Yes, it is executing. Executes the code. That's why you can, for instance, conditionally define a function. You can conditionally define a function. If you have modular attributes or top-level code, it gets executed. If you bring something at top level and you compile the code, it gets executed. You're going to see it printed out. Why? Because they do the same thing, exactly the same code path. The only difference is that Elixir C, when a module is defined, generates a bin file as a side effect. Okay, so Elixir, when a module gets defined, fine. There's nothing else to do. Elixir C, when a module is defined, generates a bin file for that module. Okay, that's the only difference. So in particular, the extensions are just conventions. So you are showing your intention, giving an extension. This is meant to be. This is not meant to be compiled, for instance, in tests, right? But it's just a convention. So the tools do not care about extensions. All right. The main phases of Elixir compilations are these ones. Now we're going a little bit more into the details. First, you scan the program, then you parse the program, and that's when you get the AST. We're going to talk a little bit about each phase now. Just let me, go through them. Then this AST is transformed in what we call the expansion phase. And after the expansion phase, translation is what gives you the Erlang AST from the Elixir AST. Okay, that's called the translation phase. And finally, you execute this last thing. All right. Indeed, it's a little bit more complicated than that because of the way modules get defined when you define a module. The way the modules are internally defined, there's a loop here, okay? But we are not going to get into this loop. Just know that it exists, so it's not like linear. If you find a module being defined, then there's a loop. But just know that exists, but we are not going to cover this loop in this presentation. All right, let's talk about scanning. Scanning means from a source file, means getting a stream of syntactical units, let's say, okay? So units of things that syntactically are meaningful, like for instance, a dot, okay? If you are doing an alias, the dot that you use for the alias, that's syntactically that's meaningful. An integer, all right? A parenthesis, string, okay? Those are syntactical units, but they do not have, let's say they do not have semantics. Well, there's the semantics that you know that the 5 is an integer and that you know that's relevant for your programming languages, but that's it, right? There's no semantics. It's just a stream of tokens, right? The tokenizer is written in this file. Erlang also ships with a tool that automates scanning, okay? But it's limited and it's not used in Elixir, and it's also not used in Erlang, all right? So, the tokenizer is written by hand in Elixir in this file. For instance, given this source code, we could get this thing, okay? So to get an idea of what scanning means, okay? And this is what the scanner would output. We see here a list of tuples, okay, that every tuple represents one token, okay? The first element of the tuple means the class of token that tuple is about. Let's say that way. It's class of token. For instance, this is considered to be an identifier. This is metadata about the position of the token in the source file. And identifier is like a generic class. Which specific token of the identifier class are we talking about in this case? Def module. At this point, def module is the token. It has no meaning, all right? And here, alias is something like that, you know? Sometimes you have only 2 elements. When you have 2 elements, means that the class itself is a singleton. So 2 is 2. There's nothing else that can be, you know, there's nothing else to specify. In that case, the third element is not written. Okay, this is tuples and a list in Erlang. Okay, because remember we are working in Erlang at this point. All right, so this is the actual thing. Right. Sometimes you are going to see this in Elixir notation, but actually the actual data structures are Erlang. So I prefer to show the real thing. All right. We are not going to get into the details of the tokenizer, but let me, just as a curiosity, let me show that there's a special rule to detect merge conflicts. All right. So this rule, if you try to compile a file that has a merge conflict, Elixir is going to tell you. It looks like there's a merge conflict here, okay? It is a curiosity, but for me it's kind of symbolic in the sense that if you work with Elixir for a while, at least I had the impression that Elixir somehow always goes that extra mile helping the programmer, right? So the error messages are meaningful. I don't know, it goes always the extra mile. And for me, this is symbolic in that sense. Okay, it has gone a little bit more and say, I'm just not blowing up. I'm telling you that maybe you have a merge conflict, which is a much more useful error message, and that statistically speaking is going to be true most of the time, right? So hat tip for that thing. Parsing. Okay, so we have a stream of tokens, all right? And parsing means taking that stream of tokens and starting to construct a structure of the program inferred from the list of tokens. That's parsing, okay? And you get the tree that represents the product. All right. That tree is not built by hand. You have a grammar. The grammar declares how is the structure of a well-formed Elixir program, and then this Jack utility generates a parser. So this Jack utility generates this file. From the grammar, you run Jack, you get this file generated. This file is big. It has like 23K lines, right? This file is not in the repository. It's generated, all right? It's getting ignored. And when I showed the line count before of Erlang, this was not included. The line count was 7,000, which is 7,000 actually written, all right? 23K are not included in that count. All right, so we have this, and this is generated. This is not in the repository, but if you go make compile, yes?
How big is the grammar? Give some impression of that.
How is the,
how large is the grammar?
It's 700 lines.
No, the not generated one, right?
Yeah.
Yeah. Before generation, you know?
So this file is 700 lines.
All right.
This file is 23K lines. Sorry, I couldn't understand.
So you generated 5 with a tool.
So it's encapsulated. You run make compile, that compiles the whole project, for instance. Dependencies of the target is going to do this for you. All right. So the Elixir hides this tooling thing behind the make tasks. You're not going to run yet manually. Well, you could, but the normal thing is to use the make targets and they do it for you.
I get it, but where is this tool is coming from? It's in Erlang.
The get, yes.
So it's coming from the Erlang.
Yeah, so, okay, so it's part of this tooling that I showed before, okay? Yet, the compile module, the code module, and binlib. Yet is the parser generator. So if you install Erlang, you get yet. Yeah, you have to install nothing additional. All right. What? Yes?
On one slide, there's the Elixir ST that's converted to Elixir ST.
Yes.
That means that there's no ST that can be used for the Elixir ST. That cannot be understood by the Erlang ST. You can use new tokens that cannot be understood by the Erlang ST.
Tokens, you mean?
Yeah.
Well, the tokens are just.
You cannot create new language that cannot be understood by the Erlang ST. Okay.
Yeah, you cannot create. You cannot create. We are constrained by everything that the Erlang and AST allows us to express. So in theory, everything that Elixir do, we could do it with pure Erlang.
Okay. Nevertheless, you have some degree of flexibility in the sense that this thing is Erlang, meaning there's tuples and atoms, but that's it. Atoms. What they mean? That's where we have constraints from Erlang. But until we get to Erlang, we are able to play with these things. Okay? Because at this point, this is atoms and tuples and numbers, and they have no meaning. So you can fit anything. So the parser expects this structure. Okay? And that's it. All right? So from the parser, you get an AST. And at that point, I don't know, if Erlang does not have unless, I believe it does not have unless, it doesn't matter. Okay? Because at some point in these transformations, some code is going to be responsible for getting rid of that unless and get something that can actually be understood by everyone. That's the thing. Okay, so the whole thing is constrained by what Erlang can express and by what the virtual machine does. That's the ultimate constraint. All right, but until you get to that point, still you can do something. Right? All right. Here, so the AST, so the parser receives the list of tokens that generated coder runs, and you get an AST. That AST represents the Elixir program. All right? The AST is very simple. There are a number of things that appear as themselves, verbatim, like atoms and numbers and strings. Okay, a number of things that if the source file have 5, you're going to see a 5. No, nothing fancy here. And then there are a number of things that are uniformly, I would say, represented in tuples of 3 elements, like these things, okay? Calls, and so these tuples in general have a head that represents what the tuple is about, then some metadata, and then arguments of the tuple, okay? And the first element could be an operator, could be something, anything, okay? So the arguments are going to be interpreted in the context of that head of the tuple, okay? We're going to see an example now. So for instance, if we have this file, okay, if the list has a head, then put here, yeah, because it's exciting to have a head. And the parser, the output of the parser looks like this. All right. Okay. These things with ellipses are metadata that I have hidden. All right. But this is the structure. Okay. So everything is Erlang. This is Erlang. Okay. So in Erlang, what do you have? You have tuples, you have lists, you have atoms. That's what you got. Okay. So this is expressed. For instance, in an object-oriented language, maybe you would have a tree structure with pointers to other branches and stuff. Okay, that's not the way it is done here. Here, it's very, very simple. Nesting, that's it. Right? So, if this is the if, all right, at this point, this is being organized in a structure, but it still does not have a lot of meaning. There was some kind of meaning, you know, implicit in the very grammar, right? But in the end, there's still no semantics here. Basically, there's no semantics here. It's just a structure. For instance, in this program, list is unbounded. It wouldn't run because list, I don't know what is list, I error. But at this step in the compilation, this does not matter. List is something that was here, that is a variable, and maybe later, who is trying to execute this is going to complain, or well, at some phase later, someone is going to check which is the environment and see that there's no list known. But the first representation is this. I don't care whether the list is bounded or not bounded at this point. Okay. In some of these things, you see quotes because in Erlang, this is an atom, okay? In Erlang, atoms normally look like identifiers. You can write anything as an atom if you put single quotes around, okay? So I guess if has to be keyword, so to distinguish from the keyword, I guess it needs this thing, the dot, for instance, okay? In Ruby, it's the same. In Ruby, you can put colon and a string, and you can put anything that's string. So symbols in Ruby, the same way, can contain arbitrary characters. Okay, you can put any character. All right. You can get a representation of the AST using code. Okay, and this is a very useful tool to write macros and inspect how things are represented. Okay, this is going to give you the Elixir representation that corresponds to this thing. Okay, so this is Erlang notation. You are going to get Elixir notation, but it's the same thing. Okay. The AST is documented here in this page that is going to be out in 1.5. All right. So this one is new and is documented there. Okay. So we have scanned the program. We have parsed the program, and we have this initial tree represents the program. The next step is very important in the in the lifetime of a program compilation, which is expansion. Expansion does a number of things to this AST. It basically transforms the AST in several ways. Expansion is mainly implemented here, okay? And it does a number of things, okay? I have highlighted a few of them, but there are more, okay? For instance, resolves aliases. What does it mean? So, for instance, if you have a module, call it M, right? In the end, that M is going to end as a module, call it elixir.m. You know that? Okay, so M becomes elixir.m. And well, and you have the alias, you can alias modules to use shorter names and everything, okay? So these aliases are going to be expanded to be the full qualified name, let's say, of the module. Requires, you know that if you want to use a macro defined in a module, you have to require the module, right? So requiring the module marks the module as required, so it requires a lexical, okay? So the compiler for this lexical scope knows which modules have been required, because then it is going to allow calling macros or not. Okay, and in addition to that, if the module is not compiled, it's going to go and compile that module at that time. Okay, when it's processing this thing, it's going to compile that module. Why? Because if a macro is used, the macro runs at compile time, so the code is needed. Okay, in the end, macros are implemented as functions in modules, because that's all. So going back to the constraints, macros are conceptually something that means what you know it means in Elixir. Okay, and Erlang does not have macros. That's where you can put the different semantic levels. Okay, so in Elixir, as a programmer, you are able to express things with macros, and then it's Elixir's job to map that somehow to the tools that it has, which is the Erlang in the end. And in the end, macros are in the end they end up being functions of a module which is all you have. All right? So macros, yes.
Compile a module to generate HT.
Yes. So if you are processing exactly that. So when you are processing the AST, if there's a require, then the module has to be compiled. Yeah. So this expansion process goes and does a number of things. All right. And for instance, macros are also expanded. To expand the macro, you have to call a function of a compiled module that is in memory. All right. So the expansion phase, there's code there. All right. Macro expansion happens at compile time, and that's why require needs to go and compile things. Because if you want to expand a macro, so if you are declaring a require, it means that in principle, you want to use some macro unless you forgot, you know. And if you are going to use a macro, since it has to be expanded at this point, an expansion means calling a function, that module has to be compiled and loaded in memory. Yes?
When was the information from config expanded? And at what step of the process is the information from config?
I don't understand the question.
So you have your configuration for this program, and that's run. No, it's not a runtime, that's defined.
So you're saying mix config?
Yeah.
Yeah, so mix config is, so you get the configuration using our functions. and mix config, it's completely separate from the compiler. So the thing that when you run your project, mix does in your project, and that's not related to the compiler, is to get the configuration and merge it, and that's just.
So it's even before you get to.
Oh yeah. So so when you're using mix, we load first your project configuration, we load the config files, and then we call the compiler.
That's why it doesn't work compile.
Sorry?
And that's why the config doesn't work compile.
Yeah.
Version doesn't work.
Yeah.
All right. Then if you look at the documentation of kernel, you're going to see a bunch of functions that are declared to be inline. Inlining those functions means that the expansion, if it detects a node that means a call to that function, it replaces the node with the aligned code. Okay, this is on here. And there's a bunch of other stuff doing in this phase, the expansion phase. And this is recursive. So if you get more macros, they are going to be expanded. And in the end, everything has to end up being special forms, which are these things that are the fundamental building blocks of Elixir. Everything is built on top of that, which is beautiful. So the kernel is this easy, or this simple, okay, or this small, that's it. All right? This is the kernel of Elixir. Everything else is built on top of this. And if you open, for instance, kernel, or open, this kind of more low-level Elixir modules, you're going to see that a lot of stuff is built on top of this. A lot of stuff is macros. For instance, if is a macro, right? Well, almost everything is macros. Even def macro is a macro, which is mind-blowing, but it's true. Okay, I have seen it. All right? Yes?
Checking out the type management where it's done.
I don't know, but it does not belong to Quartet.
What is the question?
The types, the type management. Well, I don't know.
Do you mean that dialyzer or?
I don't know about the Elixir, but I think that there would be types that by the user and
yeah, okay.
It's a dynamic language. I mean, it's a dynamic language.
Okay. Okay. Yeah.
I have a question regarding that. So would it be feasible to, let's say, add static typing to Elixir and maybe something else possible?
So the question is, would it be possible to add static types to Elixir? And so
I imagine someone forcing this. Like, would that be possible? Is that
so it's definitely, it's just that that's a very big question, because I could define a type system where I say everything, like, and the type that it gives to all functions is that, oh, it can accept everything and it can return everything, and that's a type system, right? So I'm going to an extreme here, because the part of designing a type system is exactly for you to decide what actually makes sense and what doesn't make sense. Because at the end of the day, the type system is going to reject constructs that a programmer would think that this is valid, and it would actually be valid, just that the type system cannot prove or cannot handle those particular constructs. And that's why if you ever use Haskell, Haskell has a bunch of extensions which is actually augments the expressibility of the language so you can handle those constructs. So that's part one. But the other one is like, but we already have Elixir, we already have our constructs, right? So the thing we need to do is that if we want to support all Elixir constructs that we have today, then probably the type system that I joked about in the beginning, a type system that says, I accept everything and I return everything. Sure, it's not going to be useful, but it will solve the problem. It handles all the Elixir code we wrote today.
right? But we don't want that. We want something between there that says, well, I'll be fine if not being able to write all the code that we wrote today, that we write today, in terms of getting some guarantees or getting some safety, which is what we actually want from a system. And then there's the question of like, how much actually do, so how much will we actually be able to type? And that subset of the language, is it still Elixir or not? Because it's going to be a subset. So, you know, how much we can type and how much of that is still going to be Elixir. And there are things that are actually extremely, extremely hard to type, like process and process communicating. It's literally academic research happening like in the last years. So it's a non-solved problem. And then maybe, you know, then they say, well, we're going to have a type system, I'm not going to be able to type processes. But if you take a process out of the equation, is that really accurate? All right.
All right. Okay, so these are the special forms, and you will see them documented here, but they are not implemented here. Okay, because making these ones work is what the actual, in the end, what the actual transformation to the Erlang HT is going to do. So to give meaning to something like this, in the AST, in the end, you are going to manipulate things so that the Erlang counterpart that you have, right? And for some of them, like require, there's a different thing, right? But that's the thing. So in this file, you are not going to see source code. You're going to see the documentation for them. Okay, so we have now an Elixir AST that has been transformed, or has been expanded. A much more processed AST than the original AST that came out from the parser. But it is still, you know, in the end, it's the same thing. Integers are integers, you have 3-element tuples all over the place, and then they mean the same thing. But macros have been expanded. The actual nodes are not going to be the same ones, but the concept is the same one, exactly the same one. Okay, so translation is the phase that gets you an Erlang AST from the Elixir AST. And this thing is the implementation of translation. It's scattered in a number of files. Okay, all those files implement this phase. We've seen this. Well, technically in Erlang they say this is in Erlang. This is written in Erlang abstract format. Okay, this is a detail. Okay, Erlang. So the thing is, they consider the AST like a conceptual organization of the code, and they call abstract format to the actual representation of that concept of a tree structure using Erlang terms, right? So that's abstract format, and the key of Erlang expressed in abstract format is documented in this file, right? Well, in this page, right? Okay, so tokenizer, parser with an AST, the AST is expanded, and then there's code that transforms that AST to Erlang AST. Is executing this thing. All right. This is yes. Yes.
All the negotiations are done by the Erlang.
Well, some are done by Elixir, like inlining, some, but I guess, Jose, that the core of optimizations you inherit from the compiler, right?
Yeah,
from the Erlang compiler.
Yeah, most of it is done by the Erlang compiler, up to the point that when we find out about real possible optimizations,
and contribute them to OTP to Erlang rather than doing legacy programming. So, yeah.
All right. Well, man, this thing is super interesting. So how do you execute, which is an Erlang structure? And we are going to execute it. To do this, I think this is very clever, man, because you define a dummy function in a dummy module that has the program as body. Okay, so you got the program represented as Erlang AST at this point. So what Elixir is going to do is it is going to define a function whose body is the entire program. All right, and then that function is going to be tossed into a dummy module that is built on the fly. All right, and you are going to send that to the compiler. Okay, this is done in abstract format, so everything is doing AST manipulation at the abstract format level. Okay, so defining a dummy function is done by creating manually the node that would represent a function in the AST. So you are modifying the AST, right? It's not a lot of code, but man, this is clever. So you do this and you can inspect it indeed. Okay, so if you run this script, okay, this script is using this Erlang module that has this function that gives you some information about your runtime context. Okay, this call in particular, you're getting MFA is sometimes you are going to see is an abbreviation for module, function, and additive. Okay, so this is going to give us the module, function, of an additive of my current environment. Okay, the dynamically. If you see this, it is going to say you are running a function, call it file, okay, that belongs to the Elixir compiler 0 module with arity1. Okay, so this script, which is a top level script, like it's very simple. It is running as body of a function of a dummy module. All right, so you can inspect it this way. And if you are inside the module, okay, and you have top level code here, that this number changes, okay, because these modules, due to the way module is implemented, the definition of modules is implemented, well, this index changes, and if I am not mistaken, it may also change with the parallel compiler. Okay, so this number is not relevant, but the idea that you are running inside the dummy function that belongs to a dummy module, functions have to belong to some module, dummy module. Okay, so that's the thing. This dummy module is compiled in memory with this call. This is the compiled module, Erlang module that we saw before, forms function. Okay, so I said this is implemented manually editing the AST, the Erlang AST. Okay, so you pass this AST to compile forms because you have an interface to the compiler. All right. Then you have compiled that. You can load that into the virtual machine with the code server dynamically, and that's what Elixir does. Dynamically, you do that, and then since it's loaded, it's defined, compiled, loaded into the virtual machine, you are able to execute it dynamically in that function. Okay? So you have the body of the function is your program. If you execute the function, you are executing the program with a full Erlang thing. All right? So to me, this is super clever in the sense that you have stopped doing things at the Erlang AST at the Erlang AST phase. There's still core Erlang, internal Erlang, and then you have the bytecode, but you stop it working here. You say, I'm done, just doing this hack, man, and all the work is going to be done by the compiler. And in particular, you're going to benefit of all the knowledge of the compiler about optimization and whatever, but delegate to the compiler. Finally, this dummy module, if possible, if it's some transient code, is going to be unloaded from the virtual machine. Okay, so after this, so in this line, this module is gone. In fact, the virtual machine is not going to be found, okay, because it's unloaded, just cleaning things up, you know. I believe you can. I believe the top level is there because there's no finish. Well, not sure. Anyway, if possible, you, if the code that deletes gets a change to be executed, it's going to be unloaded from the virtual machine. All right. So that's the idea of how a program is compiled. Okay. Now we are going to see the parallel compiler. Shoot.
For what I see, the Elixir compiler just translate the Elixir syntax to LST. But what's the difference doing proceeding this way, or just doing a program that translates Elixir syntax to Elixir syntax?
Yes. Yeah. So
why use the LST?
Well, with the parallel compiler, I have like a clear answer, but José is the one who knows.
Because if I generate the Erlang syntax, the Erlang parser will just convert it to the Erlang ST. I will just bring it forward. Because the first thing, so everything that Xavier is saying here for Elixir, that the language goes, parses the file or parses the string into tokens, and then it has a grammar that generates an ST. Erlang does the same thing. So if I wrote Erlang contextual Erlang syntax, then Erlang would have to tokenize it, would have to have a grammar and build the whole Erlang ST. So I'm just giving more work for the machine to do. So I cut the middleman and just go straight for the Erlang ST.
Also, when you are compiling, you are executing the code at top level. Okay, so the symbolic manipulation and the execution are not separated, and I think this is so. I don't know if technically it could be done, like writing a Bell script that from Elixir gets AST, Erlang AST. I don't know if technically it could be possible, but what is true is that there's a lot of Erlang being leveraged here that otherwise you should emulate some code, like loading the code in the virtual machine. You cannot do that. That goes beyond symbolic manipulation. You need to interact with Erlang. And the parallel compiler, you are going to see that it's totally coupled to a service that Erlang has. Okay? So that's an important point. It's not just symbolic manipulation. There's code execution. For instance, macros are expanded in the expansion file and phase, and macros are Erlang functions. Well, Erlang functions. Functions that live in the BIM. Okay, they could come from Lua L. I don't know. Okay, but you need the function. You need the macro in the virtual machine loads function to be able to call it. And so I don't know. There's a lot of leverage of a lot of things in Erlang. So I'm not sure if it could be even possible. What you could do, sure, is to target a different virtual machine. That's another topic. So if you wanted to compile, I guess, Elixir to JavaScript, well, there's I don't know. You have to implement all the things with processes and everything, like you know, all the semantics of processes. I don't know. It's not trivial, but in principle, you could target different things, maybe constraining the language. I don't know. Okay, so that thing maybe it's possible, but this particular implementation, I don't know. Okay, let's go with the parallel compiler. In Erlang, by default, modules do not need to declare their dependencies. Okay, so in a file, if there's a module in your load path, you just use it. You do not need to declare, I'm going to use this module, allow me to use this module in this file, or load this module because I'm going to use Okay, in Erlang you just write module function, arguments. By default, this work on the code for that module is loaded on demand by default. There's a mode that loads everything upfront, but by default this is on demand. This is, if any of you know Rails, this has some similarities with constant auto-loading in Rails, where you can, in a controller, you say user.something, and if user is not loaded, it's not going to be loaded in development mode by default. Some similarities, but just superficially, okay? Because constants and modules are decoupled them. So in Rails, that's a hack. It's a hack because the language doesn't have support for that thing. So you have to work around a number of things, and it's a hugely useful dirty hack, right? Okay, this is supported by the language, so it works perfectly, you know, fine. All right. Yes, I said that. And then the way this works is that there's an Erlang module called error handler. Okay, I know we are in Erlang. Okay, not in Elixir. I'm going to explain how this works in Erlang because this is related to how it works in Elixir. So there is a module called error handler, and the way it works is when Erlang is executing the code and it detects a function call for a function that is not known, then this guy is called. Okay, so the virtual machine stops working for this thing, and this thing is going to try to load that module. If it succeeds, it says, okay, it's loaded now, follow it. Okay, otherwise you get an error. Okay, that's the idea. Okay, so Elixir has its own error handler at its own code server. Okay, the code server is the module that is able to locate things and load things in memory. Okay, these are implemented in these files. Okay, so the error handler is there, and the code server is there, and it is configured this way. Okay, you can see in the implementation of that function. You tell to Erlang, that you want to use this particular error handler, this one. Okay. Okay. So in Elixir you got parallel compilation. So everything is about concurrency, and you, how do you say it? You eat your own food or something like that. Dog food. Okay. So a compiler for some languages that has as a main characteristic concurrency. Well, it's kind of coherent that it leverages all these things. It works this way. There's a coordinator module that spawns several compilation processes. There's one process per file. Okay, so if you want to compile a project that has, you get one process per file. That's the concurrency itself is bound. So it's going to be a function of the cores, number of cores, something like that. Okay, but the idea is that I am going to have at some point one process per file. Okay. Well, it's bounded by number of cores, but then this can grow dynamically because there's a waiting list that we are going to see. But basically, if you have 2K files, do not imagine that you are going to spawn 2K compiler processes. It's not going to be that. It's going to be constrained. Okay? Process per file. Okay. When the compilation for a particular file finishes, a message is sent back to the coordinator. So I am a process, I'm compiling something. When done, I call back to the coordinator and say, hey, I am done. Okay? Well, I am going to explain the happy path. Okay? The happy path is the one that is easy to explain and easy to code. Then you have a factor of 3 times the code needed to support the non-happy path. All right. So if you want to to respond to errors, there's a lot of work additionally to the happy path. But we are going to cover the happy path. Send back to the coordinator. Okay. Now the interesting thing is if an undefined, so you are compiling in parallel. Okay. what happens if this file is calling a function that belongs to a module of my project, but that module is not yet compiled. That's where the error takes place. Okay. So if we hit an undefined function, then Elixir's error handler that was configured before is going to be called. Okay, if the function belongs to a module that can be auto-loaded at that point, and there we use the code server, the Erlang code server, or perhaps the Elixir code server, probably, I don't remember this detail, but anyway, if you can load it, execute, happy path, it works. Go on, okay? Okay, otherwise, and that's the trick, tell the coordinator that we are waiting for set module. Okay, if we try to load the module, we cannot. Please wait. So we send a message to the coordinator and say, hey, we are waiting. I have a process. I am waiting for this module. Please call me back when you see this module. Okay, and I put myself in a received man. Peace. All right. Then in the happy path, that module eventually is going to be compiled. And since when you compile, you inform the coordinator keeps track of these missing modules and says, okay, I just got this one. Do I have processes waiting for this module? Yes, I have these 3 ones, message to all of them. Okay? And then you say, okay, I got the message, I just invoke the function. And then this code is super simple because this is all handled by the Erlang VM. So you have to think that that process is in the middle of that entire thing of compilation phases. Okay, it has a lot of context. It has the environment. It has it was stopped at any arbitrary point in that list of phases, and this works just out of the box. So you have all this context built. I am in the middle of a compilation, which is a complicated state. But since Erlang provides you this tool, the whole process is just paused at that point in a received flow. And when you are called back, I apply the function, which is now present, and just continue. Right? So the compilation was stopped and then resumes trivially. All right? Very nice. Okay, last section of the talk. Yes.
How good is the compiler resolving circular dependencies?
Say it again.
Circular dependencies. How good is the compiler resolving? Can they drop down to functions only now, or will it block the module?
Yeah, it's a very good question. So we automatically detect deadlocks, and we don't do it at the function level. So because circular dependencies there already, if you have singular dependencies in your code,
sure,
it's already arguably you should not be doing that. So if I decide, imagine I have a module foo, and inside the module foo, I call something on the module bar. And then I have a module bar, and inside the module bar, I call something foo. That's going to deadlock, the compiler is going to detect it, and it's going to have a deadlock into fix it. The only granularity that we have is with structs. So in Elixir, if you're saying, if I have this module, if I have a struct foo that depends on the struct bar, and then for some reason bar depends on the struct foo, we are going to resolve that. But that's the only thing we resolve. Everything else you're going to say, you cannot do that.
Why structs?
So because recursive data types is a thing,
right.
And so that's that was the main reason. Yeah.
There was another question here.
Same question.
Same question. All right. Okay. Okay. Let's finish here, which is the implementation of protocols, which is also I find it very interesting at least. Okay, protocols, protocols are modules that provide functions that are like polymorphic on the first argument. Okay, depending on the first argument, you can select one module or not. Okay, you have polymorphism on the first argument, and protocols are implemented here. Go first with this thing that allows you to define an implementation of a protocol, okay, which is def EMPL. I don't know how to pronounce it. All right. Okay, so this function, so this is an example. Let's say we have a Beautify protocol, and we want to implement Beautify for atoms, okay? And Beautify has this function called Beautify. All right. So when you do this, Elixir actually defines a module for you, which is this module. This module is going to be called beautify.atom. So it's the name of the protocol dot the name of the specialization to what you are defining. Okay. There's a bunch of metadata that Elixir then is able to read back to do things anyway. And then you have here the implementation. And well, this is technicality. This is a level of indirection that I just put it here so that you know that it exists. So so normally you think this is implementation. Well, you could say, well, this is not implementation. Implementation actually is in this target thing, which is this module. Here, a different module. Okay, so there's a level of indirection, but forget it. Okay, let's say Beautify atom is the implementation.
So you could run the implementation or write this?
Well, if you implement it, I have never done it. Well, I tried, and anyway, if you implement this, in theory, if you implement this and this method returns a different module, that's the one that's going to be used. That module returns here. So this is what is generated, and it generates underscore module, which is going to be expanded to the current module. Okay, so this is the default. So this is what the implementation generates. But in principle, you could write a different target, so a different clause for this function that returns a different module, and that one is going to be taken. That should be the one that implements Beautify for T atom. Okay. I don't know. Do you know if this is used in practice? Okay. Well, there's a level of indirection, and if you read the source code, you're going to see it. We are not going to depend a lot of this. Just know that it is there. All right. All right. So that's the implementation of a protocol. Okay. So we know what is a protocol, so we could start backwards. All right. Now let's go with dev protocol, which is the one that defines a protocol. Dev protocol defines a module with a protocol name. So in the case of Beautify, would be a Beautify module, and does a number of things. First, there it opts out of kernel dev. So when you define a protocol and you say dev, it's not kernel dev. It's a special dev that is imported from the protocol module. Okay, so change of cards there. Different dev. Then defines a dispatcher function, which is implementation 4 in EMPL 4. All right. This is the dispatcher. This is a function that given that first argument is going to select the implementation. Okay. So if the first argument is an atom, it's going to select the module that implements the functions of the protocol. That's in jargon. That's the implementation of the module for that argument type, and then enables a compiler flag called debug info. Debug info stores the abstract format of the corresponding Erlang AST into the bin file. This is a curiosity, and we are going to see in a moment why we store this thing. Okay. So basically, there's an ellipsis here, so there are more things going on, but this is maybe the most important ones to highlight. Okay. All right. So if we define this, we are going to get generated something like this. So it's a module with the name Beautify. It has the compile flag here, And then kernel dev. So this one. So the module that is generated is using kernel dev. Okay, but your code is not using kernel dev. Okay, so with kernel dev defines an actual function in this module. So everything normal here. That calls the dispatcher. Okay, so implementation 4, giving the first argument, is going to select the implementation. This is the dispatcher. Selects implementation and then calls the actual function in that module, right? With the arguments. Okay, so let's go through this one. This is implementing implementation 4 with a card, which is when this guy is an admin. Okay, and it does this. It does if there's an implementation, call it. So if this module exists, basically, which is by convention the one that should be implementing this, then you see the direction here. Okay, give me a target. The target is a beautify atom. Okay, so remember, this is giving us the module that implements the function. It's not implementation of function. It gives you the module that implements the functions. All right. Okay. Otherwise, you have to deal with the any case if needed. Okay. Well, you get a clause for each of a set of built-in types in Elixir. So I show it just this one, but then there's another one like this for integers, another one like this for floats, another one like this for lists. Okay, so you have like I don't know 12 or 13 clauses of this function, this same function that have different guards, but they are basically they have the same structure, the same thing. All right. So instead of beautify atom, it's going to be beautify integer or whatever. You know. Okay. So I don't show them, but they are generated. You have the full enchilada. The next thing is protocol consolidation. Protocol consolidation is the interesting thing in protocols, in my view. So by now we have seen the basic generation of code for protocols, but protocols do not end there. There's an optimization, and this is for me the most interesting part of protocols. So protocol consolidation is a process that is done after the compilation. Okay, for some time you had to do it manually, but nowadays in mixed projects is done by default. Okay, that's an optimization for protocols, an optimization of the dispatcher. Okay, and we are going to see now how that works. So the thing is that the dispatcher is expensive. It's expensive, especially when the protocol is not implemented, because it has to go through the pod server and to the error handler. It's expensive. Okay, that default dispatcher is expensive, but it is needed because in advance you do not know which are going to be the implementations of your protocol. All right. For instance, Elixir defines enumerable. All right. And maybe you have implementations of enumerable in your own project, but the Elixir project does not know it. So so it has to generate all those generic clauses for all possible types of data. Okay, or you have a library that implements some protocol, but that the user of the library is supposed to give concrete implementation. So in advance, you do not know which are going to be the implementations of that protocol. Right? But when you are in a project that is like a closed wall, then you know. Okay? Then theoretically, you can go inspect your entire project and see, well, this is the build. These are the implementations. There's nothing else. There's no open windows anywhere, right? So what does protocol consolidation do? Okay, it goes through, so this happens after compilation. You have the project compiler, okay? It goes through all the bin files in the project, okay? So there's a way with the code server and everything that allows you to iterate and see all the bin files that are in the load path of your project. In the load path, so that includes Elixir's own protocols, all right? it detects all the implementations in those Vim files, all implementations of all protocols. And to do that, it inspects that metadata that I showed before. And then rewrites in the protocol, rewrites the dispatcher. It goes this way. It has, there's going to be a rewriting of those 12 clauses. You have to imagine that those 12 clauses gone, all deleted. And then you have as many clauses as implementations, no more, no less. So if you had an implementation for Atom, you're going to get a card for that particular use case. If you don't, it's not going to be there. Okay, so the way to error here, if the implementation is not present, is just undefined a function, or yes, because the card is not going to be present. Okay, instead of going try to load the module with the error handler or anything. Okay, each one of these rewrites of the implementation of the dispatcher is going to return the target right away. We are going to see now before, after. And then finally, a forward clause if any is activated. Okay. So the original dispatch for Atoms, yes.
Is this done on Erlang level or on Elixir? Is it done on the Elixir AST or on the Erlang AST?
The answer in 1 or 2 slides. Okay. Okay, so this is the dispatcher for Atoms, let's say. Eh? Remember that we have one for each particular thing for each data type. Okay. Now, this process goes and gets rid of this thing and becomes this thing. All right. So it is a function that trivially returns a module. That's it. Nothing more. Okay. If there is an implementation for Atom. If there is no implementation for Atom, you do not even get this function defined. Okay? As many functions as implementations, no more, no less. And they become trivial like that. So the target is here. In this sense, the target, in principle, couldn't be exactly dynamic. Because in the end, it's hard code. Whatever returns in consolidation is going to be ending here, right? Then, well, there's a predicate that tells you if a protocol is consolidated. It redefines predicate to return true. And finally, removes this file so that the module is being redefined and recompiled. Okay, so the debug flag is removed unless it is globally set. Mix, maybe you know this. Mix writes these new Vim files. Okay, so the Vim file for enumerable, the original one is still in your Elixir distribution. You get a new Vim file for enumerable that goes in this thing, okay, in this subdirectory. And well, I was saying rewriting. What the fuck? What rewriting? I don't know. We do not have the tools of Ruby here to do whatever we want with the code. What is rewriting in Elixir? Man, let me present you this. So remember, the compile flag, that debug info flag stores the abstract format into the Vim file. All right. Well, remember the vimlib Erlang module. It gives you access to the Vim file. Okay, there's an API for accessing the Vim file. Okay, Vim files are structured in chunks, and there's a chunk that has a label, which is abstract code, that has the abstract code. Okay, so with this thing, give me the chunk abstract code, basically the small things, the ellipses, okay, but the main thing is this. You get back the original AST for the original protocol module. Then you go and modify the fucking AST, man. So the dispatcher, the functions, so it is manipulating the Erlang AST. This thing, all right? That answers the question. It is manipulating the Erlang AST, removes the implementation, and by hand, we are not going to go through this, but by hand, it is in the end writing a function by handing the AST, whose body is the whatever returns, calling the target, in the model. Okay, this is done by hand, man. Okay, so this is rewriting in memory, and then compile it again with compiled forms, and the new bin file eventually is written to this. Man, this is amazing, and that's it. I want to thank Jose because I was hammering him with Brazilian questions for 2 months. Thank you very much for that, and that's it. All right.